Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. Of course, this is a calculus problem regarding U-substitution. You can read what it says there. Evaluate the integral using U-substitution. I'm going to show you how my programs work on that, and then show you a couple of tricks here. Index 8 to get to my main menu. I'm already at U-substitution to save time, but you would use this cloverleaf here to scroll up or down. And in my menu, if you hold the second key down here and then do it goes screen by screen really fast to get, because there's 130 or so menu items here dealing with all your problems in calculus. Certainly most of your problems that were in tests that I found. So anyways, I'm in U-substitution. Press enter, and we enter. We have to press alpha first before we enter anything into these entry lines here. So we would put alpha, and then we have to put the integral sign, but x+3 divided by, make sure you use proper parentheses because the calculator knows what you're doing then. I've already done that in here to save time again, so you can see that it's here. Okay, the integral of that regarding with respect to x, which is dx, and I give you a chance to change it in case you've made a mistake. I say it's okay, and we rewrite it. Now I'm the one who, I don't know, my professor never told me how to do this. I had to dream this up myself, of course, in programming, but when you rewrite it, you put this over here because you're really trying to make the derivative inside the parentheses match this section out here, okay, with dx. So, and it took me a while to figure this out too. U, equals this, and then the derivative of that is equal to 2x+3 dx. And then you always take the constant over here, and when you're multiplying this side, you divide on this side, so du divided by 2 equals x+3 dx. Now you notice that this matches the outside of the problem. That indicates that it's a U-substitution problem. If it doesn't, then it's integration by parts or some other method, different integration rules. And so now we do the problem switching the u in there. We got 1 over u to the minus 5 and du divided by 2. Now we got to take this and put constants always come out of the integral. So we bring it outside the integral here, 1/2 outside the integral. This is u to the minus 5 du. And then we switch the u to the numerator, which makes it a exponent and a negative, opposite of what is in the denominator, and then we add 1 to it, and we divide whatever that answer is, which is the minus 5 plus 1 is minus 4, which is here. We still have the 1/2 out here, u to the minus 4 divided by minus 4. Well, the minus 4 goes over to here and multiplies times the denominator here, because this is in the denominator, right? Minus 1/8 times 1, and then we bring the numerator exponent down to the denominator and change the sign again, u to the 4, okay, plus c. And the answer is minus c, and we substitute for u the original, what u was, which is this, to the 4th power plus c. So this is the area under the curve. If you graph this right here, this is f of x. If you graph this, well, you see you can't do anything because it's an indefinite integral. If it was a definite integral, then you have ranges to find the area under the curve. And of course the x-axis being the bottom of the curve that you're trying to do the area of. So anyways, that's calculus. Hey, go to my sites, buy my programs, and sure is better than I've done all this studying for you. And you can study for hours on this stuff, never know what you're doing, never know how to do it. You can try it, but you're not going to be successful. And my programs will allow you to pass that class and certainly pass the tests. So think about this. They're only $40, and that's nothing compared to what you spend in college for many other things, including a night out in the town. So anyways, go to my site, buy my programs, and pass calculus. And I'm also available to help you. If you get in trouble, you can call me or email me, and I'll help you with calculus all I can, okay? All right, you have a good one.